I'm going to give you two functions, we'll combine them and then we'll try to find a gradient. Okay. So let's take our function f, which is going from R3 to R. That means input 3 variables, output 1 variable. Okay. So let's say f of UVW okay, and here is another function which is takes 2 inputs and gives 3 outputs. Okay, I'm going to call it G. So G of 2 inputs, let's call them X and Y. Okay, and the 2 outputs are X plus Y, X plus Y squared. So in general, this is the notation that we will use to describe a function of many outputs, right? Just separated by commas, right? So this is clearly taking 2 variables to 3 variables, okay? And now the question is, if I compose this, f composed with g, that means, so g takes 2 variables, spits out 3 variables, f takes 3 variables, spits out 1 variable, right? So this f composed with g is going to be a function from where to where? R2 to R, R2 to R. That's what this guy is going to do. Okay. And what do we want? We want gradient of this guy. Okay. So finally, it's f of g of x comma y. That's what we're looking at, right? So remember, f takes in 3 inputs, u, v and w, right? Except now that u, v and w are now actually functions of x and y, right? So this is actually what it is if I just look at the first notation over here, this is f of u, except that u is a function of x and y. Earlier it was just f of u, v, w, now u is a function of x and y, v of x and y and w of x and y. Okay. Now to find the gradient of this, if I ask you del of this f composed with g, when we define the gradient over here, we wrote the gradient as, where did it go? A column vector over here with n elements. Now when I write the gradient of this function over here, how many elements will there be? 2. And what will those 2 be? Del by del x, del by del y, because those are the 2 variables that this function depends on, right? So this is going to be del by del x, del by del y. Okay. You can also see it from here. It's a function from R2 to R. So I need to take derivative with respect to each of them. So the first thing is del of f o g by del x. That's the first thing that I need to do, where I get to apply the chain rule. Okay. Now what will this be? This f, this first component over here, it depends on u, v and w, right? And each of those u's and v's in turn depend on what? X and y. So how will I write this down? So the first thing is derivative with respect to x. That means I need to know how u depends on x, how v depends on x, and w depends on x, right? So if I write this, what is the next term that I need to write? Del u by del x. But does this capture everything? No, because f depends on v and w also. So to complete the picture, I need to do and the third term, del f by del w by del x. Okay. So you're getting the hang of it. The next, if I were to write this, del y, what would it be? Del f by del u by del y, right? and in the same way you can write these. Okay. So what is, for example, let's keep this in the page over here. Let's take an example. What is del f by del u? Look at the definition of f. Can I compute del f by del u? What is it? V minus w. I just look at this expression over here and take the partial derivative with respect to u. The only thing that survives is a v minus w. Okay. Now v minus w. So finally, when I give you this gradient over here, all the u, v and w should be gone. I should have the expression only in terms of x and y. So I can't exactly substitute v minus w into this expression, right? So what should I do? Is it substitute? So what is v? Right? So these are sitting over here. Right? So this v minus w is going to be x plus y squared minus x squared plus y. Right? So that's how I get my df by du. Right? Du by dx. What about du by dx? 1, right? Because of this expression that I'm using over here. Right? So pretty straightforward. You just have to keep your variables straight. Keep in mind, finally, what should appear in the expression? What should appear in the expression should only be x and y, because this r3 in between was just like an intermediate variable, the uvw. We needed to eliminate it. If you want, you can substitute in terms of uvw, but then to get the final answer, you have to get rid of it. So yeah, that's how you would do it. And this expression also, if you really wanted to, you can write it in a more compact notation, because you can see that, can you see grad f transpose sitting over there? Grad f transpose is sitting as a row vector and it's getting multiplied by partial derivatives of u, v and w with respect to x and y. So you can write it in a compact notation if you want. Okay. So going to multivariate calculus is not hard. You just have to keep track of the dimensions very carefully and just repeat the same logic for every dimension. Any questions on this? Okay. Now, as I mentioned previously, there is one type of function that we will spend a lot of time dealing with. So let's look at its calculus beforehand. So later when we work with it, we are at peace. Okay. So there is something called a quadratic form.